Wow, what a morning, right? We are all updated on the state of AI, and thank you so much to all the speakers. The next 20 minutes, I'm going to ask some questions. Hopefully, you have some discussion about state of AI and challenges that we still have. And are we going to have some time for questions after the panel? Okay, and there's going to be some time for questions then after the panel. So we heard some very interesting insights about semantic understanding of documents from Alicia, about using tools from computer science to machine intelligence from Irina, about the limited scope of AI and collective schema right now from Christoph. Then Naftali provided interesting perspective on how this third wave of AI with deep learning is different from the previous two waves. And then finally, Nischal was talking about tools supporting machine intelligence, such as Kubernetes, obviously, and containers. I would like to ask, so last year we were here at the summit as well, and I would like to understand what in your mind has particularly changed as of state of AI in the last 1 to 2 years? Because we are aware of the developments in general of third wave of AI, but is there something in the state of technology particularly new in the last 12 to 24 months that we should know about?
I can try. So as I said before, I mean, I really believe that this phase of deep learning, which is, as we just heard from Christoph, is nothing new, but is actually performing surprisingly well. I mean, it's much, much better than many of us expected, and I'm sure that at least those who started to think about, I think, 50 years ago or 30 years ago, are surprised. And to me, there's something really fundamentally different there, and I just want to re-emphasize it. It's taking advantage of data, a very large amount of data, in a way which was completely different from the way we did the statistical curve fitting, which was essentially a regression invented by Gauss 200 years ago. Something else happens in those deep neural networks, and I'm not quite sure that those schemata that you're mentioning or things like this are really necessary. Apparently, the machine is self-regularizing itself in a very interesting way. And I was trying to allude to that it has to do with the again, surprising, naive way we train those networks by using stochastic gradient descent, essentially, that something in the noise of the gradients is actually doing some miracles in the sense that exploiting the high dimensionality of the parameter space in a way which was not foreseen by classical curve fitting methods. And I think that it's only in the last few years that we begin to understand it and the power of this. And as far as I'm concerned, this is the phase transition. This is something completely different.
Okay, thank you.
I would like to agree, of course, with almost everything you have said. As you can imagine, you asked about progress in the last year. I'm impressed with the maturity of the field. I mean, what we have heard today is very earth to air, very practical in terms of systems that are deployable, that make it very easy for newcomers, or for new applications to be implemented on the basis of open source code and on the basis of high-level engineering. I'm very impressed with that, I must say.
Okay, thank you so much. Now, looking at the audience, probably where most of us are interested, actually, what does it mean for applications? So we've seen amazing development going on in marketing, customer experience. I believe that's probably one of the most advanced fields in AI. Given this new development in 12, 24 months, stochastic gradient descent, the new developments that have been happening, what's the next field you think that's going to be captured and that's going to be leveraged with this technology? What's the next big thing in terms of applications?
Okay, I think one of the most important things that's happening right now is the fact that artificial intelligence is really not a bubble, but AGI definitely is. People have no more focused, and so are the companies, the engineers, and the VCs who are investing to actually solve real-world problems instead of everybody just running towards saying we are going to build generalized AI. I think people understand that building generalized AI really means understanding how these systems have to work. And with just the current research that we have and the kind of advancement that we've seen, there is so much to do for the next few years. I mean, every single industry is going to be impacted by the work that we're seeing with artificial intelligence. But I'm not really, it's going to help people rather than try and say, okay, we have a new artificial intelligence model and that's going to replace radiologists. I don't think that's going to happen because we're still at a very nascent state of really understanding why these techniques work, what exactly is happening, and how they really perform when pushed into production, and can they really help businesses use this in a sort of way that empowers them. I think that's a good direction.
I absolutely agree with that. Any more point you want to add, Christoph?
I'm, of course, a kind of outsider here, thinking of a big next step. I think what is still a limitation of the present situation, you need these big data. You need, if you go by the algorithmic approach, which is still very viable, which drives all of the digital transformation anyway, you need to focus large markets in order to have the data, in order to amortize your investment. And that is a strong force in the sense of standardization of our life, which I find is a problem for us. What a truly intelligent system will be able to do is understand the situation, the present situation, be situation aware, and serve you with the needs of that situation in a way that is completely or largely independent of what happens elsewhere. So I think a big next step will have to be understanding systems which also have an understanding of the goals that play a role in the situation. At the present time, goals are always in the heads of the designers. You know, if you want to have a Go machine, you tell the system it's all about winning the Go game, and the machine has no idea about life otherwise. What you need is, of course, intelligent systems that have an understanding of the goals, that have their own goal hierarchy, and have an understanding of the goals of the customer. That is going to be the next big step.
Yeah, totally agreed. One more point?
No, I just want to add something which I think is extremely important. So far, machine learning and deep learning in particular is focusing on what we call sensing and perception. And I think that it's moving now, quickly actually, to what we call sensing acting systems, which is also the motor aspect of behavior, without which I really believe that we'll never have understanding. So we need to close these loops. This happens right now through what we call deep RL, deep reinforcement learning, or actually in applications like autonomous vehicles or robotics. And as far as I'm concerned, this is going to be a major shift in the application of this type, and it's happening even without understanding, by the way.
Yeah. So Irina, you're actually in the field of understanding physical systems, right? So application in autonomous vehicles would be definitely something of interest to Siemens. What's the biggest challenge going forward, and when can we expect that system to be out there?
Well, actually, what I'm about to say is my personal opinion. It has nothing to do with the company I work for. But there are definite challenges in interpretability of the models, and I see that as a trend that is increasing. The notion that it's not just good enough to be able to predict on something, but you really need to be able to ensure that whatever decision is made based on a model can be traced back to why it was done, because this will have consequences in mobility, definitely, but in other areas. So in insurance, it will have its consequences, and at every given point, we need to be able to interpret reliably those models. And I think that's right now one of the biggest challenges.
Do you want to add anything to this point?
Well, it was in that direction. You mentioned Go. And then the question was, what's moving on in this artificial intelligence in the last year or 2 years, you said? But do we realize that this intelligent machine that we have is just giving the output that we ask? So we give an input, we have the machine, and then we want this output, and then we are just training this machine to do this. The machine that plays go, full stop. So something that I would like to see is that, and I've started seeing some papers about this in the conference that I've been attended, and it's that I cannot afford, let's imagine that I'm in a company, which is not the case, but in any case, let's imagine that I'm in a company and I don't want to have 100, 200 different deep learning neural networks for each one of the mini tasks that I have in my company, just because this customer needs this, that customer needs this other thing. So one of the big things here is, can we have a machine, a deep learning architecture, a system that it's able to do whatever we want, not having different ones? So can I know how to play Go, and then I know how to drive a car, and I know how to read a document, and I know how to infer some information from my customers, or these sellings from customers? So do I really need these different systems? So I think that this is a bit what we should do, because at the end, humans are able to do many different things. And the learning that we have from one task can be extended, and it can be inferred, and there is some reasoning there, and then we have some basis that we are sharing among all the different tasks. So I think that this is still pending.
Yeah, that's a very interesting point, Alicia. And I think, in my mind, it's somehow not contradictory, but on one hand, we would like to have a general system, general intelligence that can do many things. On the other hand, we want to have some kind of predictability of how the system is going to behave. And just to give you an example, a couple of years back, I started a company in robotics, and we were doing convolutional neural networks for predicting human movements and how the robot would react. And one of the issues we had was ISO certification, because we were not able to, with certainty, say how the system is going to behave. Because it's going to behave somehow with some statistical error. Is that, in your mind, an issue, this kind of challenge in terms of predictability of general intelligence that we all would like to potentially see?
Certainly it is a big issue. You know, the automotive industry is working towards self-driving cars, and there is an ISO norm, 26262, which says you will have to prove the functioning of your system in any situation. And they all feel protected because that applies to all the companies. None of them can do that. And you cannot do that with human drivers, of course, but human drivers are not covered by the ISO norm. You know, think about if you have a very complex system, there's no way you can know the details inside the system. Think about the way people take responsibility for what they do, which we customarily do. If we do something, we are asked, why did you do that? We usually have a good theory of why we did it. We can relate to general goals, etc. We get by this in the judicial system, as you know. People are taken to be accountable, or they are put away in an asylum, of course. And I think the future of this issue will have to be that the system itself also models what happened in itself in relation to general behavioral schemas. I did this because I wanted to avoid that danger, and I had no choice, whatever. There will never be, ISO norm 26262 will never be fulfilled to the letter. Full accountability will always be a shaky issue.
I just wanted to add that there's actually a huge field around the ethics this training, because it's not just the technological part, it's not just how you train them, but there's a strategy to how you train things. And that affects how you choose your data when you're training, and then that affects actually, for instance, in fields like reinforcement learning, what kind of strategy are you going to give priority to? And that's a very human discussion. That's not really an engineering problem. It's a matter of principles, it's a matter of goals. And that's going to have to go back to not the engineering teams, but there's conversations that need to go on around privacy, around priorities.
I would like to wholeheartedly agree. I'm nervous about the task of giving a general artificial intelligence being a set of goals, ethical goals. I'm very nervous about it because we are not even good in our own domain, a human domain. We have dark regions in our own behavior. The group instinct, for instance, which is so responsible for atrocities, is never talked about for reasons I don't fully understand. So it will be a tremendous task to endow artificial systems, truly autonomous artificial systems, with a goal system that they can live with and we can live with. And this is not a technical issue at all. It is an issue that will have to involve philosophers and politicians and all of us. A great topic to talk about.
Thank you so much. You touched. I'm just going to interfere for a second. You touched about a very important topic, which is informing the public and engaging in this debate, because it's really a small group of people that understands really what the state of AI is, and then the rest of the public kind of has a very, very broad understanding, and therefore there's a lot of fear of actually what is possible with AI. So in the US, there's this initiative called The Gradient, which aims to explain what the level of AI development really is in normal words, so that an average person can understand where we are, and it's supposed to provide very transparent information on that. Do you think that's a way to go, to kind of bring the public closer? What kind of debate, or what should we do as experts in the fields to involve the rest of the society in that debate?
So I just want to relate again to the issue of ethics, which is of course very related to your question. So first of all, the problem with ethics is there's no absolute ethics. I mean, maybe it may be a shock to some of you, but we don't have a good theory of ethics. It's always context dependent. It's always subjective to some extent. It always depends on the scale of time we're thinking about and so on. So I don't believe that engineers are the right persons to design ethics rules. And in some sense, my belief is actually that eventually those AI systems will have to form their own ethical rules, as scary as it sounds, simply because I don't trust any finite group of people to do it better. But the point is that, again, so this requires some sort of conversation with the public, and that's, I think, what we are trying to do here, among other places. I mean, know the limitations of the technology, know what it's good at. I'm actually not sure that it's so limited as some of us think. I mean, for example, the same machine that plays Go's with very slight modification can play chess or can play other games. The same machine that can diagnose one disease, for example, can be altered to diagnose other diseases and so on. Medical AI, for example, is one of the greatest challenges where both ethical issues are very important and generalization, transfer learning, all those issues are important there. And I think that actually putting AI in medicine and in actually government planning is going to be a real challenge and a very important one.
Very interesting.
I think when it comes to ethics and being transparent and talking about what AI can really do, the biggest problem that we have with AI is there are only few companies that can do it. At this point in time, all of us are running behind data, and there are few companies that have the data and that can do insane stuff that we never thought about was possible. And they start publishing about this, they write blogs about this, and for everybody who don't understand systems, they think, okay, we have the Terminator that's going to pop up any second. But I think they should there should be a policy by the government itself in terms of how research is being conducted with regards to AI, how the research teams come together to publish works and make data available to every small company, every individual who wants to work with it. And I really like the idea of what Gradient's trying to do with taking away the math, taking away the whole craziness of what deep learning systems that only people who are with special skill can understand, to actually teach people what it's really trying to do. And as engineers, because we're talking about engineers, I think every engineer is responsible for being ethical too. And recently, we saw a few engineers who've left certain organizations because they weren't happy with what the organization was doing. And I think as engineers, we need to take that stand. We need to draw the line and say, if we are not sure of what we're doing with artificial intelligence, it's better to back off.
Yeah, totally agree. So I think the public institutions are going to definitely play a bigger and a bigger role, including the European Commission, on that topic. And with that, we have around 5 minutes for questions from the audience. Feel free to raise your hand, and then I believe somebody from the team will pass you the mic.
Yeah, hello, good morning. My name is Günther Tauer. The last sentence was very interesting, and I have a question a little bit to the AI community. As we are working for 10 years, my colleague now for 25 years, is why the AI community is a little bit paralyzed, regarding making a little bit prognostics. What will goes on with AI? Well, if we are following certain paths. The thing is now going on in China that the social scoring, that's one aspect as a hashtag. The next will be, the mixture of CRISPR-Cas6 and AI. And I think it's more dangerous than the nuclear bomb had in the past. So we have to do something, though. I would say the scientists have gone down to the street. There was a march against for scientists in the US as well, here in Germany, and demonstrating for the scientists, for the science. So they have go to the population. That's the point. No, we will really come to a chaotic situation, regarding migration, regarding climate, and all this stuff. And that's not the theory, that's a practice. And we have already done some prognostic in the last time. So I'm not one that we have Black Mirror one day.
Thank you so much for your question. Yes, you said the word Black Mirror. I don't know if you have already seen some of the TV episodes, but I remember an interview with the directors, and they said sometimes we are really scared of seeing how similar and how close we are in reality with what we have seen on TV. And the case of China and how our personal score can really say yes or no to certain paths are in my opinion, is something to really, the chicken skin. And in this case, I think that ethics, as we were suggesting here, is one of the things that should be incorporated. Indeed, we already have this when we have the self-driving cars. People are more and more interested in what happens, which is the decision of the machine when there is a crash, an imminent crash. So shall we take this decision or that decision? Because it maybe means that the pedestrian that's there will die. So, and this is something that we are seeing in some conferences, especially in the ones concerning AI. But going back to your previous question, there is that website that tries to show this to the society and make AI closer and decrease a bit the expectations, because it seems that AI can solve everything right now. And, it's still very controlled. No matter the generalization, yes, I agree. But still, there are two ad hoc methods for each one of the tasks. And I think that the website is one of the things. The other one would be media and the news. They are selling things as so great that sometimes you see that we have already discovered a new thing. We just did a very tiny step.
I totally agree. Actually, especially in physical systems like robots, people generally have a perception that more things are possible than actually are. So even grabbing undefined objects is extremely difficult to solve, while a normal educated person would think that it's an extremely easy problem to solve because it's so easy for us humans. Anybody in the audience having any other questions? Last question and then the coffee break.
Hi, I think this question is mostly to Christoph van der Malsburg, just about your talk before, about this idea of general artificial intelligence. I'm not a computer scientist. I know a little bit about neurobiology, and if I understood you correctly, it's kind of what you were saying is that, well, the way the human brain works, you have a finite number of neurons, and depending on that, they have unique patterns of excitability, which then gives some kind of cognition. Is that kind of what you were seeing as the future of general artificial intelligence? Did I get that correctly?
Well, in order to get general intelligence, you need to have a data structure that has two properties. Number one, it has to be able to express whatever needs to be expressed. Like if you look inwards, there's a lot going on in your mind, and your neurons are capable of creating, for instance, a representation of this scene here for you. That is one requirement. And the other requirement is you need a generic mechanism of organization. You cannot be required to program the thing specifically for specific tasks. You have one generic program which deals with all particular situations. Now, classical artificial intelligence takes a data structure, bits. They are completely general. You can express whatever you want with bits in a universal Turing machine, but you have to care for the organization, for the interpretation, and so on. That's the Achilles heel. Neural networks have a mechanism of organization, not only statistical learning, but also, although grossly neglected, network self-organization. But the present interpretation of neural networks is a lousy data structure. It cannot express the complexity of a situation like this here with lots of relations between objects and relation to abstract concepts, for instance. The brain has a data structure that does both. So my answer is simply yes, I believe if we follow the lead of the brain in terms of what the neural structure actually is and does and how it is organized, we will be able to create general artificial intelligence.
Thank you so much to our panelists, and I believe now is time for a coffee break, right?